Yes, great 12 learner. I hope you're doing good. Join me in our lesson today, which is called Financial Mathematics, and we're going to do specifically about loans. Okay. Yes, let us continue. Yes, once again, you're welcome. Now, this is Financial Mathematics, and this is part one. Now, in financial mathematics, we need to know about the following. Okay, from previous grades. Number one is called simple interest. Now, simple interest, you have your money initially, okay? You have your money initially, then the money is going to grow with a linear scale, okay? It grows linearly. So with simple interest, your money is gonna grow linearly, like this, okay? Now, the money is growing linearly, in other words, like this. Now, when you have your money, okay, starting from here, it's gonna grow linear, like a straight line, okay? We call it what? Simple interest. And the formula is A equals to P into 1 plus I times N, whereby the A is the final amount, the P original amount or the principal, then the I is the interest rate per period, and the N is the number of periods, okay? Then with the compound interest or inflation, now here the money is going to grow, okay? But will grow like this, like a parabola, like this, okay? Now in this case it's called what? Compound interest, okay? The formula says A equals to P into 1 plus I power N, where A is the final or accumulated amount, and then P is the original, or you can call it principal amount, and then the I is the interest rate per compounding period. Don't forget, we are very careful here. If we are compounding monthly, we divide I by 12 and multiply N. If the N is in years, multiply it by 12. And if you are compounding half yearly, you divide I by 2. And then if N is in years, you multiply it by 2. Okay. And then if we are compounding quarterly, we divide I by what? By 4. And if N is in years, multiply N times 4. All right, let's continue here. And then another one is called depreciation. Now, something to depreciate, it loses value. Are we together? So, now talk about straight line. Again, if something is up here, it's going to lose value like this, but it's going to lose it linearly, okay? It will lose it what? Linearly. So starting from somewhere here, we're going to lose value as we come down like this, okay? We are losing value, we are losing it linearly. And the formula, it says A equals to P into 1 minus I times N. And don't forget that the examiners, they are always very specific. They're going to say that calculate according to straight line depreciation, okay? This is our formula here, whereby A is the final all depreciated value, okay? And then P is the original value, then I is the depreciation rate per period, and N is the number of periods. Okay, then another one is called reducing balance, okay? Reducing balance here, depreciation. Now reducing balance here, we are also losing value, but now this time we're not losing it linearly, but instead we are losing it like this, okay? Something's losing value, okay? Losing value like this. You see it's going down like this, losing value. Okay, now because here we are rising up, our amount for 1 and 2, the amount is bigger than what? Bigger than the principal. Even here, amount bigger than what? Than the principal. But here, because we are losing value, the amount is less than what? The money invested. Even here, amount less than the principal. Okay. So here we are using what? Reducing balance depreciation. And the formula says that A equals to P into 1 minus I, close bracket, power N, whereby A is the final or depreciated value, and then P is the original value, and then I is the what? The depreciation rate, where N is the number of periods. Okay, note that if we talk about the compound interest, straight line, reducing balance, and okay, And simple interest, the N is the number of periods. The N is what? The number of the periods, okay? And then another one is called the effective and nominal interest rates here. Now, the I effective is called the annual interest rate. And then the I norm is called the nominal interest rate. That would say per annum compounded more than once a year. Okay, then M is the number of times interest is compounded in 1 year. We look at examples to do this with this formula here. Now, this formula does not come in your examination sheet, but you must put it in your head. Now, today I'm specifically going to talk about the present value, okay, the present value formula. Now, the present value formula is the formula which we use when we talk about the loans, the mortgages. Okay. Now, why is it called present value? Now, if somebody badly needs money, that person needs it when presently. So, I repeat, this is called present value formula because if somebody needs money, you need it what? Presently. Like you cannot go for a loan and then they say, we're going to give you the loan next year. That will not be acceptable. Okay, so we're saying that the present value of an annuity is defined as the collective value of all the payments, okay, with interest removed or reversed exactly one interval before the first payment. Now, on a timeline, when they give you the loan, this is the which is the loan, okay, they give you the first interval, the first gap here, then you start making a regular payments. Now, what you see here as X, these are the regular payments. Are we together like this one here? These are the X, we call them the annuities or the regular payments so that they are paid at equal time intervals. Okay. Now, I was saying that we can use the following formula to calculate the present value of an annuity. I didn't write it down again. Now, the present value formula, we use PV, okay, equals to X, this X which means the regular payments, okay, into 1 minus 1 plus I, okay, then to the power negative N. This n must be made a negative power, otherwise you're gonna get the answer which is very wrong. Okay, and then I is still the interest rate per period. Don't forget in this particular case the PV is the present value, okay, and then the X is the payment, and the I is the interest rate per interval, and the N is the number of payments. See, now I'm saying that the present value formula is used whenever the total, listen carefully here, I'm saying that the present value formula is used whenever what? Whenever, I start from here. When do we use it? We use the PV formula whenever the total or large amount is paid or received first. Do you hear that? First. And the payments or the small amounts, okay, and the what? And the payment, it is all the small amounts are made later. So this includes all the loans, okay. It is also used when a sum, okay, when a sum of money is set aside in order to make regular withdrawals in the future. For example, if money is inherited and you don't want to waste your money, you can take it in the bank and then the bank will start giving you every month end. Remember, you take maybe the 2 million today, then every month end they give you maybe 20,000, then you can enjoy your life. Okay, that's also part of the formula which we use called the present value. Okay, now we have an example here. Let us do it together here, this example, and we see what we're talking about here. Okay, the question says that Mpo can afford to pay back at most 8,000 per month. Okay, now if they said per month, it means that that is what? That is going to be regular time interval. So can pay back how much? 8,000 per month on a car loan. Okay, the interest on the car loan is 15% per annum, okay, compounded monthly. What did we say? Divide I by 12, multiply years by 12, okay. They will say he will make his first payment 1 month from now, you see, that 1 month gap from now, and he will repay the loan over period of 5 years, okay. They say, what is the price of the most expensive car Mpo can afford? Now, the most expensive car will depend on how much loan Mpo can get. So, we're looking for the PV in this case. So, we're going to say that our PV, okay, equals to X, that's the monthly payment, into 1 minus 1 plus I, okay, power negative n, divided by what? Divided by I, okay. So, here we go. Now, our X in this case, we have, he can pay 8,000 maximum, okay. Open brackets here, 1 minus 1 plus I. Now the I they said 15%. Now 15%, don't do it in your head, put it there like this, okay. Then because we are compounding monthly, divide by what? By 12, okay. And they're saying 5 years, so power negative 5 times 12, okay. And then close the bracket here, divide it again by I, okay. Our I is still 15%, okay, 15%. And we are dividing by 12 because they're compounding monthly. Now, as you see it here, please don't waste your time. Get your calculator like me and put it straight. Let us do it together. And you see here, if I get my calc here, okay, and I put in my sum as you see it here. What do we have here? We have the fraction, okay, that is 8,000, right? 8,000, and then open bracket here, open bracket here. Then we have what? 1 minus, okay. This one is also another bracket again here, open bracket then 1 plus. Now, what we have here is a fraction, that is the 15%, okay. So you say 15, then percent 50% here, all together, 50%, 50% here, and then close the bracket. No, go down then, divide by 12, okay, all together, and then scroll here, power what? Power negative what? Negative 5 times 12, because we are compounding every month end, okay. Then come here and close the bigger bracket, then go down, divide by I, which we said is 15%, okay. That's 15%, 15%, and then divide by 12, okay. Divided by 12, let us see how much. Now, Mpo can get a car which is 33,000, okay, which is what? 33,000, that is 336,276, okay. So we have 336, then 276. So Mpo can get a car of this much in cash. So this is the loan which he can get, and so he can get a car which is worth this money here. Hope we are together, okay. That's our answer here. Now today, after knowing how to use this future value formula, we want to talk about something very important, which is very common in your tests. Okay, that's called the outstanding balance on the loan. The outstanding balance on the loan. Now, the outstanding means that you have not yet paid that balance. Okay, but you have paid some part of the loan, but you didn't pay the balance, not yet. Okay, so we are saying that the outstanding balance on a loan at a given moment in the is the amount that has to be paid to settle the loan. The outstanding balance given by the following formula. Outstanding balance equals to the loan with the interest to date minus repayments with the interest to date. Now, the loan with interest to date, we use the compound interest formula. For example, if you are paid you've made how many payments? You've made, let's say, M payments, okay? You're going to have it here as what? As the P, this P is the loan, into 1 plus I, the power M, altogether. And then now what you see here as the loan with the interest to date is this one here, guys, okay? This is our loan with the interest to date. Remember, it is being compounded either monthly or whatever case may be. Then minus repayments with the interest to date. That means the future value to be used, okay? And that's what we see here, the future value formula. So minus the future value. But note that in this particular case, we still have the same M. The M which is here should be the same M. That means the payments made here should be the same payments which we use in here. They must tally, okay? Then you can get your what? Your outstanding balance, okay? So it's saying that for a normal loan, where the first payment is made one interval after the loan was received, and then no payments are missed, the outstanding balance immediately after the nth payment is given by this formula here. Are we together? Now, this formula we use it when we know how many payments have been done. However, if we only know the outstanding payments, if we know the outstanding payments to be done, then we don't have to use this formula here, but instead we use this one like this now, okay? Now, in that particular case, we'll see an example on that as well. Then we do it like this. I repeat, I also can also get our outstanding balance, okay? Outstanding balance by using the pending payments, okay? If I say pending, I mean you have not yet paid them. Like if the house was to be paid for 20 years and your aim is let me say 7 years, okay? Then now you're gonna use the 7 here, of course times 12, né? Then when you come here and you want to use this other formula, then you don't use the 7, but because the house was for 20 years, okay? And then you paid for 7 years. Now here, you're going to use now at the 20 minus what? 20 minus 7, which is going to be 13. So now if you use the remaining years to pay, now you can also know the outstanding balance by using what? By using x, okay? By using x into, okay, into 1 minus 1 plus I, the power negative n, okay? Negative n divided by what? Divided by I. Divided by I. Okay. Alright, so but for today, we look at this formula here and look at the following examples. Okay. We have the following examples here. Alright, now they say here exercise 4, we're saying that Tabo, okay, Tabo pays off a loan of 80,000 rands over 5 years period. He makes half yearly payments, okay? He makes half yearly payments starting 6 months after the loan was granted, okay? Was granted and ending in the end of the 5-year period, okay? So nothing was missed out, né? They say then the interest rate is 18% per annum compounded semi-annually. Okay, did you hear that? It is 18% per annum compounded semi-annually. Now the question is, what is his half-yearly payment? What is his half-yearly payment? So when it comes to our question like this now, what we want here now is what? Is the half-yearly payment, okay? So we are going to do like this now, okay? Do like this now here. Let's get some space here. Okay, this. We're looking for the x, okay? Now remember that our formula, we said that for the loan, we use the present value formula, okay? We use what? This formula. So it says that our PV, which is the loan, PV, present value, equals to x, open brackets here, then 1 minus, open bracket, 1 plus I, the power negative n, okay? Divided by what? Divided by I. Let us now substitute. Now they gave us the loan here. It is 80,000, 80,000. 80,000 here. We're looking for this x here. Okay, so then 1 minus 1 plus I. The I is 18% per annum commodity semi. So here it's gonna be the 18, okay, 18%. Because we are compounding semi-annually, we divide by 2 altogether. And then we're talking about 5 years, power what? negative 5 times 2, okay, and then divide by I again, which is what? Which is 18%, okay, 18%, and then divide by 2 again. So looking for this x here. So guys, like I said, don't feel sorry for the calculator. Punch in this thing the way it is direct. You're gonna say, I'm gonna cross multiply here, so I'm gonna say that is gonna be 8,000, okay, the 80,000, okay, times the 18%, okay, 18% divided by 2 altogether. Then now I divide by this part on the numerator, leaving the x. So I divide by 1 minus 1 plus, this is 18%, 18% divided by what? By 2, the power negative 5 times 2, okay? Negative 5 times 2. Okay, let us now get our answer together here. Now what you see here, we put it at once on the calculator, don't forget that, guys, okay? So here we go with our calculator now, bring it here. Now it's starting with the fraction button here, that is 80,000, 80,000, which you see here, right? Then now multiplied by fraction again here, we have 18%, 18% shift here, 18%, 18%, okay, then over what? Divided by 2, divided by 2, then everything divided by 1 minus, open bracket, then 1 plus, okay, then another fraction here, we have 18% again, 18%, right, 18% here, then divided by 2, we said power what? We said to the power of negative what? Negative 5 times 2, because it was being compounded semi-annually. We get our answer here, which is 12465. 12465. 12465. 12465. Then comma what? It is comma 61. Okay, comma 61. So it's going to be his monthly payments. Hope we are together. Okay, let us proceed now. The question continues to say here that how much does he owe immediately after the 10th payment? Now, if they talk about 10th payment, which means it's not yet done, because it was let us find out now. Now that's what he has paid so far, the 10th payment. And we said that if you have got the payments done, you can use the first formula here to get your outstanding balance, because how much does he owe? That's what we want now here. Okay, I'm going to show you here. We said that if you know the payments done so far, then you can use what? This formula here. Okay, you can use this formula here for the outstanding balance. Okay, and where is it here? Yeah, I think here, but I'm going to put it down here. We said that where we have the present value, okay, I mean where we have the compound interest formula minus what? Minus this one here. We have the loan with the interest to date after the 10 payments minus repayments with the interest to date. Okay, so he has made 10 payments so far. Okay, so I'm going to use this formula here, this one here. All right, so here we go, here we go. They're saying that how much does he owe immediately after the 10th payment? So we're gonna go like this now. I'm gonna kill enough of this now. I think you are, so I can get enough space here. Need to get some space here. Okay, now remember he borrowed 10,000 for by loan. Okay, okay. So for this matter, the outstanding balance, okay, outstanding balance equal the payments that okay, we say it's gonna be P into 1 plus I the power n minus the future value formula altogether minus what? The future value formula. So minus x excuse me, minus xc, open brackets here, then 1 plus I to the power n minus 1 divided by I. Now he has made 10 payments. So remember that we had 80,000. So this is 80,000. Then open brackets here. 1 plus I, which is they said the 18%. Okay, that'll be 18% here. 18% here. Now because we are compounding semi-annually, we divide by what? Divide by 2. Okay, now he's made how many payments so far? 10. So power 10. Now these 10 payments, these are not years. We just put 10 the way it is direct here. Okay, then minus. Now the x this one here, that's 124. Okay, 124. 12465. This is the monthly payment, ne? Comma 61. Open brackets here. Then 1 plus I, that is 18% still. Okay, 18%. Divide by 2, because we are compounding semi-annually, to the power 10, the same 10 which is here, it's power 10 here, then minus 1, okay. Now divide by I again, okay, divide by I again, which is still 18%, okay, 18% divided by 2. All right, so now I'm going to get this answer first, then minus this one here. But I can put everything at once anyway, like I told you before. So here we go. I want you to watch this as we put it now, okay. As we put it now, our calculator, come on, where are you? Now the calc is here. Don't feel sorry for the calculator, like I said. So we have the 80,000, okay. We have the 80,000. We have the 80,000, okay. 80,000 altogether times open bracket. Now this is the loan growing, ne? Growing by compound interest. That is then 18% here. So we said 18%, right? Divided by 2. Why? Because we are compounding semi-annually. And then here, close the bracket. Power, how many payments? They said 10 payments, okay? So 10 here. Then we say now minus the future value. That is the same. We are using the same monthly payment. Don't forget, that's 124. 124, okay? 124. 12465. 12465 here. And then comma 61, okay? Comma 61. Are we together? Open bracket now. Open bracket again. Then 1 plus, okay? Bracket, fraction button here again, 18%, okay? 18% shifty, 18% here. Divided by 2. Why? We are compounding semi-annually. Don't forget, guys. Then now you're gonna say here, to the power still 10. To the power still 10, okay? Power 10. So then now we're gonna say here minus 1, okay? Minus 1 here, minus 1. Then divided by 18%, that's fraction also. 18%, 18% here. Divided by 2. Why? We are compounding semi-annually. So our answer is 0. So mean that here in this particular case, because this is 0, negative 0 comma something 0, so it means it's not owing, as the loan has been paid in full. Loan has been paid in what? In full. Okay. Yes, I think we are fine now. Don't forget, the moment you see a negative, it means the loan is fully paid. Ne? Okay, next example here. Example 2. They say here that Sanelli, okay, Sanelli, let us look at this Sanelli here. Question B, pays off his 2 million home loan with monthly payments, okay. This is 2 million loan, 2 million loan with monthly payments over 20 years, ne? Okay. Then they say that they say here that the interest on the loan, on home loan is 10.8% per annum compounded monthly. Okay. Then they say, what is his monthly payment? What is his monthly payment? So the loan is 2 million. The rate is 10.8% compounded monthly for 20 years. So being a loan, we are going to use the formula like I showed you already about the present value formula. Okay. And in this case, we are going to say our PV, don't forget the formula, our PV, okay, our PV equals to X, open brackets here, 1 minus 1 plus I to the power negative N, okay, divided by what? Divided by I, okay. Now the loan is 2 million, okay, 2 million, 2 million equals to X, which we are looking for, open brackets here, 1 minus 1 plus I. Now they're saying 10.8%, okay, 10.8%, then divide by now we are compounding monthly, so divide by 12, and being 20 years, we say power negative 20 times 12, power negative 20 times 12, okay, times 12, and then divided by, okay, by I again, which is what? Which is 10.8% by 12 again here. So we're looking for X here. Like I said before, don't feel sorry for the calculator. Eh? Put in the money at once, okay? This is 2 million times the denominator here. That is 10.8%, okay? Divide by 12. Then divide by the numerator besides X. Eh? That is 1 minus, open bracket here, 1 plus 10.8, okay? 10.8%. Divided by 12, power negative what? Negative 20 times 12. So here we go. Here we go with our X here. Let us punch in together. Now our calculator, where are you? Where are you? Now we're going to say here that fraction button, okay, then the 2 million, the 2 million, the 2 million, 1, 2, 3, 4, 5, 6, then times fraction button again, that is 10.8%, okay, 10.8%, that's it, here, then over 12, right, over 12, then all over 1 minus, open bracket, 1 plus, fraction button again, that's 10.8, 10.8%, 10.8%, then divided by 12, okay, don't forget the power, we say power what? Power negative 20 times 12, 20 times 12, hope we are together, so here we go. All right, so the monthly payment is actually 20,372, 20,372, 20,372, how many cents? And 2.24. So this is the monthly payment. Yes, now part B, they say here that what is the outstanding balance on his loan after 10 years? Okay, don't forget the loan was balanced after 10 years. So to understand here, after 10 years, he has paid 5 million plus, but then the loan has gone to 5 million plus, but then the money he has been contributing is 4 million plus. So this outstanding balance on the loan afterward, after do this part 2. All right. The question was saying that Sanele pays off his 2 million home loan with monthly payments over a period of 20 years. The interest on the home loan is 10.8% per annum compounded monthly. What is his monthly payment? This is the answer which we just got now. Now they say that what is the outstanding balance on his loan after 10 years? Okay, what is what? What is the outstanding balance, okay, on his loan after 10 years? Don't forget the loan is for 2 million, okay, and it is supposed to be a period of 20 years. Now, so far, this guy has been paying this money every month, and this is the interest rate, which is 10.8% per annum compounded monthly, okay, compounded monthly. So Now to get our outstanding balance, we have a formula which I just told you some minutes ago, that the outstanding balance, okay, outstanding balance is given by what? This is question 2, okay, is given by this formula. That is the value of the loan for 10 years minus the future value, the money invested with the interest. So the loan was for 2 million, okay? Now our N is going to be the 10 years, because that's what he has been paying so far. So 10 times 12, which is 120, okay? So now here, our outstanding balance is going to be the 2 million must grow for 10 years, okay? 2 million, then open bracket here, 1 plus I, that's 10,8, okay? They say 10,8%, but they are compounding how? They are compounding monthly, so divided by 12, okay? Now after 10 years, it's gonna be power 10 times 12. Now this is the loan, okay? Then now minus the money which has been invested with the interest, is gonna be with the future value. Okay, so here we are gonna write now. Remember that every month end is paying some money. How much is that? That is 20,000 something. This 20,372. 20,372. This is 20,372, comma what? Comma 24. Comma 24. Comma 24. Okay. Comma 24. And then now open this formula here, open brackets here. Now we open brackets again, that's 1 plus I, that is 10,8, okay, 10,8%, okay. Don't forget, we are compounding it monthly, so divided by 12. So for 10 years, that's power 10 times 12, like we said, okay, then minus 1, now divided by the I again, okay, that's to say the 10,8%, okay, by what? By 12. Okay, so we are going to put everything here as you see it on our calculator to get our answer, which is the outstanding balance. Okay, so here we go with our calculator. Let us do it together and you see how it works. Okay, so when I get my calculator here now, let us punch it in together and you see. So calc, where are you? So here we have the 2 million. Okay, we have the 2 million, 3, 4, 5, 6 altogether, multiplied by open bracket. The money is growing, that's the loan, then plus 10,8%, okay, that is 10,8%, and then divided by 12 because we are compounding monthly, okay, and then to the power 10 years, that's power 10 times 12, 10 times 12. Now this money, you're gonna say minus the future value. Don't forget the monthly payment here, that is 20. It's paying every month and 20,000, 372, okay, comma 24, comma 24, then open bracket again, then 1 plus, okay, 1 plus the 10,8, 10,8, 10,8%, 10,8%, then divide by 12 because we are compounding monthly, okay, then to the power 10 years, power 10, again multiply by 12, don't forget that. When you are done, you should say minus 1 as you see it in the formula here, close bracket now, then divided by I, which is also 10%, divided by 12, which is 10 what? 10%, divided by 12, okay, divided by, so 10,8, it is 10,8, 10,8%, right, divided by what? By 12, and then get your final answer. So here we go. I think you can see my answer here. It is 1491157. 149149117. 1157. Okay, 1157. Any commas, comma 68. Okay. Now this is the outstanding balance on the loan after 10 years. Okay, that was part 2. Then part 3, what must we do? You see here that 10, what percentage of his payments during the first 10 years went towards the interest? What percentage of his payment, they're saying here, what percentage of his payment during the first 10 years went toward the interest? Okay, so here we go. Now, first of all, we need to know the amount paid after 10 years. How much was that? Okay. Now, the amount paid after 10 years, I'm going to call it A10. Okay. A10. Now, for the 10 years was paying every month end. So 10 years multiplied by 12, multiplied by the monthly fee, this one here. That's what he was paying every month end, okay? That means 20,000, okay? Then 372, then comma 24, comma 24. Then how much is that? Calculator, how much is that? Come on, we're gonna say here that the 10, okay, times 12 times every monthly what payment, that's 20,000 something, 2372, comma 24, comma 24. Are we together? What do we get here? We get 2,444,66. We get 2,444,66. Okay. And then what? Let's check it again. 8,8. Okay. 8,8. 8,8. 666. Then let's see. 8,8. So this is the money so far this guy has been paying for the 10 years. In case he has paid 2 million plus, okay? Then we're going to ask ourselves, how much of the capital has been paid so far? So how much of the loan has been paid? So the loan paid so far after 10 years is going to be the original 2 million, okay? The 2 million all together. Then minus the outstanding balance, which you see here, okay? Which you see here, that is 149 minus 149, then double 1, okay? Then 57, comma what, comma 68. Let's find out, calculate again. Come on, tell us now. If we say that the 2 million, okay, 2, 3, 4, 5, 6, the 2 million minus 149, okay, 1157, okay, then comma 68, what do we get here? So you get 508842. 50, okay, you get 50, you get 50, 88 what? 42. 8842, comma 32, right? Comma 32, comma 32. Now this is the loan paid so far. Are we together? This is the loan which has been paid so far. Okay, so for that matter now, we're looking for the interest then. Now to know our interest, okay, the interest paid, what we do, we are going to get the money paid by this guy, okay. Don't forget amount paid for the 10 years, ne? This money here, paid for the 10 years, this one here, minus the loan paid so far. So I'm going to subtract this money, okay, this money here, this one, the amount paid for the 10 years, minus part of the loan which has been paid so far, this one here. Okay, so I'm going to say here that the money paid minus what? Minus the loan paid. Are we together? Yes, like I said, we do what? We're going to subtract this money paid, okay, this money here paid, that money paid, this one minus part of the loan paid to see the interest that the bank has made. So I'm going to say the 2,444, okay, then 668 minus 8, minus the 50, okay, 5088 42, then you comma 32, comma 32. Calculator, come on, tell us now. Okay, so this 244 minus the answer here, right? Yeah, that is 2,344. 66 together 8. Are we together? Comma 8 minus the answer which we have on the calculator. This is what we have now. That's now the interest, That's 193582. 193582. Let's take it again. 193582. 6,48. 60,48. Now that is the interest we have paid so far, but because we are looking for the percentage, are we together? Looking for the percentage, then now what do we do? What do we do? We are going to divide this interest, like they said, okay? Divide the interest here. Check the question one more time. They said here that what percentage, next check, what percentage of his payments during the first 10 years went towards the interest? Okay, so we're going to divide now this money, okay, this money here, this interest out together, that's 19, divide 1935, okay, 1935, 82, 6 out together, comma 48, divide by what? By the money popped out, that is 2 million something, that's 4 here, then 6, okay, 8, comma 8, then we set times 100. Okay, so calculator, come on again. So this money, which is the interest, okay, that means answer divided by that divided by the money paid, that is the 2,466, right? 668, comma 8, okay, then times 100, because we have percent times 100, okay. So here we get 79,19%. 79,19%. Okay, are we together, guys? Hope we are together now. So that's the percentage which I wanted here. Alright, so we have to stop here. Now, if you have understood this video, please don't forget to subscribe and like the video. But however, please, if you understand now, do these questions for me. When we meet again, we are going to do what? We're going to mark them together. So do this one here. Okay, that was for 2020, for May, June 2023. Okay, do this question here. Also, do these questions here as well. This one here. And then lastly, do this question here too. Alright, thank you so much for watching. As we finish up the questions, I will see you again in our next video. Bye bye.